There are, I showed you the other day, I showed you on Thursday, and I would encourage you, again, very few people take me up on it. I showed you on Thursday, I gave you the outcomes. I told you that there are 7 types of problems. You should get better at identifying what type of problem it is. They should be back there as well. Okay? I told you the other day that certain ones are what I would consider grade 11 review, and the only ones that we're going to sort of cover in grade 12 are horizontal ground at an angle, like so, off a cliff projected horizontally, like so, and off a cliff projected at an angle, like so. Okay, so those are the 3 sort of grade 12 types. That said, you need to be able to handle the other 4. They're more grade 11. But the concept is the same. Okay? So I've given you those different types of problems. You can expect one of each. Okay, so some basic reviews, some basic ideas from Thursday. This is the quick version of what we did Thursday. Vertical and horizontal motions behave independently of each other. That is, despite having a horizontal velocity VH. Now, I am using VH. That's sort of my old format. If you want to call that VX, you can, right? X component of velocity. I just tend to continue to say VH.
Why
Horizontal. Right? So VH, VX are equivalent to each other. Taryn, some glasses today?
No, it's just in this class. Every other class I said far back.
Every other class you sit far back and you can see.
Like, no, I can see it every other class.
Oh. Is that not big enough?
Is there far sighted?
Do you have glasses?
Yes. I can still see the whole.
So you have. Anyways, so despite having a horizontal velocity VH, the projectile has the usual vertical acceleration of gravity. In other words, AV, right, the vertical component of gravity is now minus 9.8, right? You should also know that VH stays the same at all times. This is all review from Thursday. I wouldn't bother writing any stuff. Do you want it? Horizontal velocity stays the same at all times. In other words, the downward acting force of gravity does not affect the magnitude of the horizontal velocity, right? As the object goes sideways, right? As it goes sideways, which way is gravity? Down. So the sideways isn't affected by the down gravity. Is there any horizontal acceleration? There is not. Use the vertical velocity VV in all calculations relating to height of rise, time of rise, anything having to do with the rise, you use the vertical velocity VV, or I guess if you prefer these days, VY. Right? Since it is only the vertical component velocity which causes movement in the horizontal direction. In other words, as the Pac-Man flies through the air at an angle like this, it is the vertical component which determines how far up it goes and how long it goes, right? The horizontal just tells you how far it goes sideways. The range, if you will. Are you looking for something?
Yeah, but outline.
Oh.
It's not.
Okay, so question number 4. Sorry, question number 4. Question number 1. I don't know where I got number 4 from.
Yeah.
Probably page number 4. Oh, I know why, because it was like, yeah. Okay, so here's your clicker question. A bullet is fired from a gun and air resistance is negligible. What does the word negligible mean? So small that we don't need to worry about it. The muzzle velocity is 120. Muzzle velocity is a word you're going to have to know. It means how fast it leaves the gun. The initial velocity. It's 120 meters per second. How far away will the bullet land if it takes 2 seconds to hit the ground? Okay, so the bullet goes like this, right? The question is, how far away? We're talking about the horizontal range, right? DH, if you will, or DX,
No, but that has to be.
displacement or distance. And the time is 2 seconds. How far away will the bullet land? I'm going to start it, and then I'm going to do my attendance.
Is the gun like level?
The gun is level, horizontal.
Oh yeah, there it Where you have to be zero.
Have you got an answer?
This is the only person we're doing.
One at a time. Okay, what's the answer? No math, no real. It's B. Why is it B? Because it goes horizontally. It's going 120 meters per second, and it takes 2 seconds. So it's going right. Oops.
Oh, I never thought of it.
120 in a second, and then another 120 second, right? The horizontal and the vertical are independent. There is no effect on each other. Okay, question number 2. A rock is thrown off a cliff at an angle of 30 degrees and a speed of 10 meters per second. At its peak, what is the vertical acceleration? A rock is thrown off a cliff at an angle of 30 degrees. At its peak, right there. Whoopsie. Right there, what is the vertical acceleration? I guess that would be AV, right? What is the vertical acceleration? You should know this. I've given you the answers. You might have to think. If you want, you can draw a picture. Yeah, it's just a picture. Right? This is the speed. This is the angle. But I want to know the vertical acceleration.
I think it should be 0, but it's wrong.
Oh, you think the 0 should be up there?
Opposite should be up there.
I just said you think it should be up
I
there.
think it's, yeah.
Okay, fair enough.
I realize that's not right. Because it's not going up or down what's at the top.
But it wants to know how long it's going to take to get, right?
No, it's asking for the vertical acceleration.
Yeah, it's like how much it changes when it's at right at the top, right?
Yeah.
Yeah, but the change right at the top or not. It's at the top.
But it's not asking for a change.
That's what acceleration is.
Quick P time.
That's what B, that's like formula for.
It looks math-like.
FA is still stick, yeah.
Yeah.
Vertical acceleration the entire time is gravity. Gravity doesn't know when I throw Angry Pac-Man at Dawson when it's at the peak. Gravity doesn't go, oh, I see Angry Pac-Man is at the peak of his flight. I should turn gravity off momentarily. Sorry, I missed that. Stop, Mr. Bernard.
What's another two though?
Meters per 1/4.
Squared, okay, yeah.
Nope.
You might.
Oh, actually, hang on, let me think. Give me 1/4. Yeah. I haven't really thought that far ahead, but we'll probably be okay.
It's not for sure, but there's a good chance.
Okay. So, gravity, does gravity ever turn off?
Oh.
So the answer, always, for vertical acceleration is going to be? Negative 9.8. You want to put that on your cheat sheet? Should we start getting your cheat sheet ahead of time?
Yeah, probably.
That's a strategy that I've suggested in the past. I don't know if anyone's ever you know, you could even start like a draft cheat sheet and then take that and condense it, right? That would be something you could do. Well, whatever. The vertical acceleration is always 9.8. Is it not?
Yeah, because it's always gravity, because it's only vertical.
It's always gravity. Gravity doesn't know it's supposed to turn off and on. Okay, question. Same dude, same cliff, same rock. Rock is thrown off a cliff at an angle of 30 degrees and a speed of 10 meters per second. At its peak, what is the horizontal acceleration? What is the horizontal acceleration? None of that was being recorded, so I'll just go back here and quickly re-say that VIV is 0 and VIH is 24.
Where on your drawing would you put VIH?
Well, I mean, I guess you'd put it right here, right? I mean, it's still the same location, right? H. Right? Okay, so my first question is, find the time of fall. How long does it take for the car to fall? Now, do we need to know how far it goes sideways? No. We only care about this is time of fall. Take away all things horizontal, only vertical. Because we know that it takes just as long to fall as it's going sideways as it will to when it's just dropping, right? Remember I did the 2-ball drop thing over there the other day? It was kind of close. Okay, so how far is it falling? 45 meters. Problem, Talia? What is the vertical acceleration? Negative 9.8. The vertical displacement is 45. What's the VIV? 0, right? So it's a D equals VIT plus a half AT squared question. Grade or first unit kinematics. The displacement is minus 45. Why minus? Because it's down. What is the VI? 0 plus 1/2 minus 9.8 T squared, right?
Yep. That looks right to me.
Okay. So that means that T is going to be the square root of minus 45 all over minus 4.9, I think, right? And where's my calculator? There it is.
What is it, American?
Three 3.03, right you are. Takes 3.03 seconds. What if you just dropped the calculator off the edge of this cliff? 3.03 seconds. Does it matter that the car is driving sideways? No, they are independent of each other. I'm going to keep repeating that. Now, how far from the base of the cliff does the car land? How far from the base of the cliff does the car land? We're talking about this distance here, right? Okay, how do you figure out DH? We did it in the first question with the bullet. How fast is it going? 24. How long is it going 24 for? 3.03 seconds. Right? V bar equals D over T. 24 is D over 3.03. Multiply. Right? What is the car's velocity at impact? Now, if the car's going 24 horizontally to begin with, how fast is it going horizontally when it lands? 24. How fast is it going vertically? No, not 0 anymore. It's going down. Right? It's not minus 9.8. That's the acceleration. You need to know the vertical speed. VF equals VI plus AT. Oh, I just didn't wait long enough?
No.
Sorry, man. VF equals VI plus AT. Which VI do I use?
0.
Yeah.
Which VI number do I use?
It depends which one you're solving.
I'm solving for this.
VI.
0. It has an initial vertical component of 0. What's the vertical component of acceleration? Minus 9.8, and our time is 3.03. That's what you're going to say, Dawson? I apologize for not letting you finish. You know I didn't mean it. 29.7. And that would be meters per second, right? Okay, now, what's the impact velocity? What do I have to do? It should be negative, sure. What do I have to do? Got to use some Pythagoras, right? So, V squared is equal to VH squared plus VV squared, or 24 squared plus 29.7 squared. Does it need to be negative in there? You're just going to square it. You're just doing Pythagoras. $38.2. Do we need an angle?
Yeah.
Yep. Opposite over adjacent, so that's going to be the VV, 29.7, the VH, 24. Second function tan, 29.7 divided by 24. I get 51 degrees. 51 degrees, and how would you describe it? Did we get like a north, south, east, west kind of thing in the question? It's just kind of going down at an angle. You would describe that as BTH, below the horizontal.
So, if you're going faster when you go up the cliff, you're going to hit the ground harder.
Yep. Horizontally, yeah. Bingo. Yeah, if you're ever forced to drive off a cliff, go slow.
Okay.
Good physics tip for you there.
Why would you be forced to grab them?
Okay. So, David Letterman. Yeah. Good tip. David Letterman was a late night host. He was on before Colbert. You guys probably never watched him because you probably didn't stay up that late. But when I was your age, I'd stay up and watch Late Night with David Letterman. He always did wacky things. One of the wacky things he used to do was throw watermelons off buildings. Because
In like populated streets?
no, like usually they would go to like a practice fire tower and into a parking lot.
Okay.
He would also throw other things. I have a video of him throwing other things. It's amusing. Oh, I'm going to show it. It's like one of my favorite things to show kids.
Oh, it's hilarious.
But first, you got to do this question.
Oh, okay.
It is. So David Letterman, that's him in his youth, used to throw watermelons off city building. If he throws a watermelon off a 25-meter high building at a speed of 1.5 meters per second sideways, how far from the base of the building does it land? So it's exactly the same. I'm looking for this DH right there. It's exact same. So you're going to find the time of fall. D equals VIT plus a half AT squared. The displacement is minus 25. The VI is 0. 1/2 of minus 9.8 T AT squared, right? So T is going to be the square root of 25 over 4.9. And here's a tip. Is it always going to be the square root of the displacement over 4.9?
Yeah.
Because that's the only thing that changes.
Just memorize this number. So memorize 4.9, ready to go.
2.26, I guess. Okay, and then you're going to go what?
V bar equals D over
V bar equals D over T. 1.5 is equal to D over 2.26. So multiply that number. And I just take that whole number, because I still got it in my calculator. I got 2.258769757. Got it right there. Why press clear?
Why would
Already got it there.
That's something I would do.
Times 1.5. I get 3.4. What did I say the answer was?
3.4?
Excellent.
Yeah, I just figured it would be round.
If this was a test situation, I would obviously take 3.3. I've seen the work, right? When you're doing it by clicker, it's got to be exact. Okay.